Before we begin today's lesson, take a minute to do this warm-up problem. This is an investigation out of your textbook, and what it's asking is for several different variations of the same question, really. We have a coin toss, which they're going to call event A, and we have a die roll, which they'll call event B. So obviously A has two possible outcomes, heads or tails. B has 6 possible outcomes, 1, 2, 3, 4, 5, 6. And we're asked for a few different combined events. Let's just do the first one together. The probability of getting a head on the coin and a 4 on the die would be one way that can happen out of 12 possible outcomes. And then what they're asking for here, P of A, that's the probability of just the first event, so just a head on the coin toss. Well, there's a 1/2 chance of that occurring. P of B would be the probability of a 4 on the die roll. There's a 1 in 6 chance of that occurring, because 1 in 6 of the die outcomes would be a 4. So pause the video, fill in the rest of this table, and then answer question number 2. Hopefully you got these results for the table, filling in the different values for the intersection A and B, as well as for the individual events, the A and the B separately. As you look through this table, there's a pattern that connects the intersections here with the individual probabilities here. And that pattern is multiplication. 1/2 times 1/6 is 1/12. 1/2 times 1/2 is 1/4, and the same thing continues through the other rows. So to write this in general terms or in symbols, what we can do is to say that the probability of A and B, the intersection, is equal to the probability of A times the probability of B. Now this is a very important rule to remember. And will generally imply that you should multiply. There's a catch, as there often is. The catch is, notice in this problem, the two events A and B had nothing to do with one another. If you know the outcome of the coin toss, you can't make any prediction about the outcome of the die roll, and vice versa. What that means is that the two events are independent. If they were not independent, then we would need a modification here, because knowing that A had occurred would affect the probability that B occurs. So now let's look a little bit more at both of those cases, when they're independent and we can use this rule, versus when they're dependent and we have to do that modification.